Welcome to the Lab 11 Ether channel configuration. So first of all, what is Ether channel? So Ether channel basically refers to a technology that combines multiple physical links into a single logical links, and it has mainly two advantages. First of all, it increases the bandwidth of the link. So if this one link is 100 Mbps, so the combined bandwidth will be 200 Mbps. And secondly, it also provides redundancy. So if one link breaks, one physical link fails, if one interface fails, we still have the connection intact through the second link. So these are the main two advantages of Ether channel, and it can be configured through two main protocol. One is the LACP, that is Link Aggregation Control Protocol, or the PAGP, that is Port Aggregation Protocol. So we can bundle up to 8 physical interfaces into a single Ether channel or single logical link. So this another advantage of this Ether channel is that it prevents loops as well. As we can see here, these red dots here shows because these ports are automatically blocked by the STP because we are forming a loop over here since we haven't configured the Ether channel. Once we configure the Ether channel, the whole multiple links are considered as a single logical link, and both link will be active. So it also prevents loops. So in this particular topology, we will be configuring two Ether channel. One is between switch 0 and switch 1. This will be a layer 2 Ether channel. And the second is between switch 1 and switch 2. So the switch 1 and switch 2 are basically multi-layer layer 3 switches. So this Ether link we will configure as a layer 3. So let's get started with the task. So the task 1 is to assign IP addresses to the PC and the gateway. So I have already done this configuration. I have assigned the gateway as well as the IP address to the PC. So this is IP address, and this is the gateway that we will configure here on switch 1 as an SVI. The next task is to configure switch 0, configure VLAN 10 and assign port to it, and then configure the Ether channel. So let's get started. So enable global configuration mode. First of all, let me change the host name to switch 0 as per the topology. And the second thing that I will be doing is to create the VLAN 10, and let's suppose I will name it as PC0 VLAN. And next is I will assign the interface, this one, fast Ethernet 01, to this VLAN to which this PC0 is connected. Let me configure the port into access mode and assign the VLAN 10, and that's it. So we have assigned the port to the this VLAN 10 that is connected to the PC. Next is we will be configuring the Ether channel, this one. So, and these two interfaces are fast Ethernet 02 and 03. So let me get into both interfaces, and here I will configure the Ether channel group 1 and mode active. So what are the options? Option active, enable the link aggregation control protocol automatically. So active and passive are basically used for LACP. Passive is enable LACP only if LACP device is detected. So if you configure passive over here, on the other side you must configure active so that they can negotiate, or you can configure active on both side as well. So I will configure active over here. So the channel group shows that I am using the LACP, which is a standard open standard protocol. So I have configured the Ether channel for fast Ethernet 0, 2 and 0, 3. And now I will go into this Ether channel interface, port channel 1, and I will configure this. So now all the configuration that I will be doing on this, I will be doing it on this Ether channel interface instead of the physical interfaces. So mode trunk, because I am configured this Ether channel as layer 2, so switch port trunk and allowed VLAN 10. I'm only allowing the VLAN 10. So that's it for this configuration for this switch. So I will save the configuration. So now I will go to the switch, next switch, which is switch 1, and I will configure the next task is to configure the VLAN 10 and SVI on switch 1, as well as to configure Ether channel with switch 0 as well as with switch 2. So let me go into CLI of switch 1, global configuration mode. First of all, let me change host name to switch 1 as per the topology. And first of all, let me create the VLAN. I can name it to again PC0 VLAN. And now I will configure this layer 3 interface or SVI for this VLAN 10. Interface VLAN 10, and I will assign it the IP address of 10.1.1.254 with the subnet mask 255.255.255.0, and I will use the command no shutdown so that it's enabled. And now I will configure this SVI, the Ether channel with the switch 0. So I will go to the interfaces, fast Ethernet 0/2 and 3. It is giving an error. That okay, sorry, I didn't specify the range. Fast Ethernet 02-3, and I will configure the channel group 1 and mode. Here I can choose active or passive. I am choosing the active. Exit. Now I will go into the Ether channel, and I will configure it as a trunk encapsulation dot 1 q, and I will configure it as a mode trunk, and I will allow VLAN 10 on this trunk. So that's it. So as now we can see it is doing the negotiation. It will come up in a while. Now the next is to configure my another ether channel with the switch 2. So for that I will go into the interface range gigabit 0/1-2, and since I am configure it as a layer 3, I will use this command which will make it layer 3. And since I am using another ether channel on the same switch, I will give it the number 2. Again I will use the mode active, exit. Now I will go into the ether channel 2. Again it is layer 3. This command is not required, so I will give it the IP address because I already specified it as layer 3, 10.1.2.1, and subnet mask of 255.255.255.0, and exit. So that's it. I have done the configure both the ether channel layer 3 as well as layer 2 on switch 1. Now I will go into the switch 2. Let me first save this configuration. On switch 3, enable global configuration mode. First of all, let me the host name to switch 2. And again, I will go into the gigabit interface 01-2. So I just forget to specify the range. And again, I will specify it as a layer 3 and channel group 2 and mode active, exit. Now I will go into the ether channel face and assign it the IP address, which is 10.1.2.2 and subnet mask of 255.255.255.0. So that's it. We'll save the configuration. And now some test cases are some show commands. So let me first go to switch 0, and this is the command that you can use to show your ether channel. So it shows us that we have one port channel. The SU stands for S is that it is a layer 2 ether channel, and U is that it is up or in use. And these interfaces, these are the part of this ether channel. The protocol used is LSAP, and the P here shows that they are both used in the port channel. So let me use the same command over here. So this port channel, layer 3 port channel are just coming up. But anyway, let me show the ether channel summary command. And here we can see the port channel 1 or the ether channel 1, it is again up, and S is, it is a layer 2, and the second is it is also up, but it is not layer 2, it is layer 3. And these are the interfaces that are shown or that are part of these particular port channels. So this is a very handy command. And now let's do some testing. I will do some testing to, you can also use the command over here, show IP interface brief. And here we can see that we have this SVI, it is up, and this port channel is also assigned the required IP, it is also up. So the port channel 2 has assigned an IP address. Port channel 1 is layer 2, so IP address is unassigned. So now let's do some testing. And the test that we will be performing, the first test is to, let's suppose, first of all, ping the gateway from the PC, which is 10.1.1.254, and sure enough it is pinging. Now let me ping the switch 1 IP address, it is also pinging. Let me ping the switch 2 IP address. And it is not pinging because we need to configure a static route from on this switch 2 to switch 1 so that it knows the IP address of this PC. So in any way, let me now check the working of this ether channel. So as we said that the ether channel gave us I'm trying to continuously ping it. I don't know the command for it. Anyway, let do a test scenario. Let me break or delete this one link over here. And now let ping the SVI again. It should work. As we can see, it is working. Although one link is down, the SVI is still pinging. So in this way, it gives us the redundancy. And once you configure the static route over here, you can do it. You can do the same for this ether channel as well. We can test it. This ether channel as such. I can ping the switch 2 IP from switch 1, which is 2.2, and it is pinging. And if I break one link, it should have no effect on the connectivity. It is pinging. We can now check the Ether channel and we can see that one link is now down of the Ether channel of both the Ether channel, but it is still up. The Ether channel overall logical interface is still up. It is not down and the connectivity is still working despite disconnecting or deleting one link. So that's it for today. I hope this has been informative. So please subscribe and we'll see you in the next video.